Question 5. Read and complete the following proof. The following is an informal proof of the side-angle-side similarity postulate. Alright, I would pause here, and I had a duplicate tab open. Since it's specifying that it's a side-angle-side similarity postulate, I would scan to the side-angle-side similarity theorem and look to see if they have a proof that's set out similar to this, so that I could use this as a reference if I wanted to. So that's just what I would do, because I would want to be able to bounce back for a reference if I become lost. Okay. Plan for the proof. Construct segment DE on the triangle ABC such that segment DE is a midsegment of triangle ABC. Construct triangle IJK such that triangle ADE is congruent to triangle IJK. So what they just said is that they would make this triangle up right here to be the exact same triangle there. So they would just copy this and make it right there, duplicate it right there by the side angle side. Then if triangle ADE is congruent to triangle IJK and triangle ADE is similar to triangle ABC, okay, so triangle ADE is similar to triangle ABC, this larger one, and triangle IJK is similar to triangle ABC by the transitive property of similarity. That is because this little triangle is the same one as that little triangle, and it's similar to itself. And since this one is similar to the larger triangle, that means this triangle has to be similar to the larger triangle as well. So that's the plan for the proof. Okay, so now given that segment AD is congruent to segment IJ by construction, segment AE is congruent to IK by construction, segment DE is parallel to segment BC by construction, and angle A is congruent to angle I by construction. Prove that triangle IJK is similar to triangle ABC. Okay, so they listed out the whole plan right there. So that's a good reference as well. It says the reason is the reflexive property of congruence. So I know that congruence ends up with this symbol, and I know reflexive means it has to be the same thing on both sides, like a reflection in a mirror, reflexive property, so it has to be the same thing on both sides. So that's my context clues. And so if I scanned, I would first notice that there's two options. There's angle B is congruent to angle B, and actually there's three options. So they listed all of these out. So how are we going to filter these out? Well, I'm going to ask myself, we're trying to prove two triangles that are congruent. So I'm going to ask myself, which of these angles is in both of those triangles? And I noticed right off the bat that angle A is part of this smaller triangle right there, and also part of the larger triangle right there. So I know that it's going to be angle A, and I'm just glancing. The other option was angle B. Angle B is only in one triangle. That's not going to help me prove that two triangles are similar because it's only in one triangle. So that's how I would eliminate angle B and the other angle as well. So for this A, it's angle A is congruent to angle A. And then this next one, it says that angle DEA and angle BCA are corresponding angles. Definition of corresponding angles. And it says angle DEA is congruent to angle BCA. Okay, well, these are the same angles from the previous statement. We had the definition of corresponding angles, So I'm going to be leaning to look for something that has to do with corresponding angles. For B, alternate interior angles theorem, no, it doesn't have corresponding angles in it. Corresponding angles postulate, yes, that is what would logically follow based on just those context clues. Okay, and then it's stating that triangle ADE is similar to triangle ABC by blank. Alright, this is looking back to what has been given. So, or what has been proven. We proved the angle DEA right here, is congruent to angle BCA right there. So there's one pair of corresponding angles. And then in this statement, it was angle A. Remember, angle A is congruent to angle A. You can scroll down and verify that again. So notice that angle A right there is a corresponding angle to itself in both of those triangles. So if I were to draw a, so if we were to just draw ADE and then ABC, again, remember we had the pair of corresponding angles right there and right there, and then angle A congruent to angle A. So we had two pairs of angles. So it is the angle-angle theorem postulate, or similarity postulate. So C is the angle-angle similarity postulate. Now there's not another one. What I would encourage you to do, since the example proof was given to be in a paragraph proof, I would write this down as an example for the side angle side similarity proof, so that you could use it like on a checkpoint or in the exam.